Hello everyone. In this video, I'm going to explain improper integrals and also how to evaluate them. So first of all, it's important to understand the definition of an improper integral. An integral is said to be improper if one of the following conditions hold. The first condition is the lower limit is negative infinity or the upper limit is positive infinity or both. So one of the limits are undefined like negative infinity, positive infinity, or both of them are really large, undefined. So if we take a look at this example in this diagram, so we have integral 1 to infinity 1 over x squared dx. So here we notice that this is an improper integral. The reason being because the upper limit is plus infinity. Here we notice that the limits of integration are constant. They're bounded, so like 0 to 1, but the integrand itself becomes unbounded at x equal to 0 because it involves 1 over 0. So it involves division by 0. So from this discussion, we learned that an integral is called improper if. So first you're going to take a look at the limits of integration. If any of the limits of integration is infinity, negative infinity, or positive infinity, we said the integral is improper. Or the other condition is, so you might have finite limits, but the integrand might become undefined or it might become unbounded at some point in the integration region. Now let's see how to calculate the improper integral. So in order to calculate the improper integrals, we use the concept of limits. We replace the lower or upper limit or both by a variable and then take the limit as this variable go to the original value. So which limit we replace by a variable depends on which one is infinity or which one makes the function unbounded. I'll explain this through the example. So I'm just taking the previous example. So we're going to find the integral of 1 over x squared dx. So we are interested in finding this area that is bounded between 1 and infinity of this function 1 over x squared. So here we notice that the upper limit is infinity. So we're going to write limit b approaches to infinity and we're going to replace the upper limit by this new variable b. And we're going to calculate integral of 1 over x squared dx from 1 to b. And now we solve this integral and let's see what's the integral of 1 over x squared dx. So we know that integral of 1 over x squared means x raised to power negative 2. So increase the power by 1 and divide by the new power plus c. So integral becomes negative 1 over x. So I'm just going to rewrite that here. So we get limit b approaches to plus infinity, so it's positive infinity. So integral is negative 1 over x and the limits of integration are from 1 to b. So we apply the limits. So limit b approaches to plus infinity, so negative 1 over b, and then minus negative 1 over 1 is equals to, so this limit is 1 over infinity, so that is 0. So we got 0 and negative is positive. 0 plus 1 is 1. So this area, the shaded area, is equals to 1. So I would also like to discuss the case when we have finite limits of integration but the function or the integrand becomes unbounded. So let's take at the other. So if you want to find the area from 0 to 1, so what we're going to do in that case, so we'll try to find integral of 0 to 1 over x squared dx. So this same function that we worked with before. So in this case, we notice that, so if we put 0 here, so that is at 0, the integrand becomes unbounded. So we have to replace 0 by a new variable. So we will write limit a approaches to 0 plus a to 1 over x square dx. All right, so now again, so we know that integral of 1 over x square is negative 1 over x. So we write limit a approaches to 0 plus. So integral is negative 1 over x, and the limit values are from a to 1. So when we put the limit values in, so it would be upper limit, which is negative 1 over 1, minus lower limit, which is limit a approaches to 0 plus negative 1 over a, and we get negative 1. So negative and negative positive, so 1 over 0, so that is positive infinity. So our answer is positive infinity. So we notice that this improper integral diverges. It does not give us any particular convergent value. So improper integrals can have a finite value as the answer, or they can not have any particular result. They can just be unbounded or divergent. Let's try a couple of more examples. So let's try to figure out this integral from 0 to 1 under the curve 1 over square root of x dx. And again, here we notice that, so if you put x equal to 0, so this integrand becomes unbounded. So it means it's our improper integral. Since our limit, lower limit, is the reason why the integrand becomes unbounded, so we're going to write limit a approaches to 0 plus. So in place of 0, you write a, 0 to 1. So a to 1, square root of 1 over square root of x dx. So I'm writing 0 plus because we know that we are considering all the values which are greater than 0. So let's take a moment to think about what is the integral of 1 over square root of x dx. So it can be written in the power form like this, and then we know that we increase the power by 1 and we divide by the new power, so we get 2x raised to power half. So this integral can be written as limit a approaches to 0 plus, so 2 square root of x, and the limit goes from a to 1. So we do lower limit, upper limit minus lower limit. So when we apply the limits, so we see that we get 2 square root of 1, which is just 2, and then 2 times 0, which is just 0. So overall, we get 2 in the end. So in this case, we got a finite answer in the end for our integral. Let's try for now what happens to this integral if we consider the limits from 1 to infinity. So here the upper limit is infinity. It's an improper integral. So we write limit b approaches to positive infinity 1 to infinity, 1 to b 1 over square root of x dx. As done before, square root 1 over square root of x, integral of that would be integral of that would be 2 square root of x, and then the limits of integration are from 1 to b. So in the next step, we get limit b approaches to plus infinity 2 square root of b minus 2 square root of 1. So this is overall this is plus infinity, so we get plus infinity minus 2, so which is overall divergent, so we got plus infinity in the end. So your improper integrals might end up giving you a finite answer or just unbounded answer in the end. So the gist of this lecture is that for any improper integrals, we replace the limit of integration that makes the function unbounded or the limit of integration which is already infinity or negative infinity, so we write that as limit b approaches to infinity, and we replace that by the new variable b. I hope that makes sense and you liked this video, so please do watch the future videos as well. Thanks for watching.